Hello everyone, this is DSA Zindabad. Today we are going to solve the 28th question of our square DSA sheet. And the question is valid parenthesis. So now let's look at the problem statement. Given a string S containing just the characters, these all are the like opening, closing, opening, closing, opening, closing brackets. Determine if the input string is valid. An input string is valid if open bracket must be closed by the same type of bracket. Open bracket must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type, right? So now let's try to understand the problem statement, right? So let's take this example. This second example we have. The question says like we have three type of bracket like open, close, right? So what we'll have? We'll have three type of bracket. First one is simple bracket, these curly braces, and the square bracket. These three brackets we have, right? So now like we have opening, right? And for closing we have, oh sorry, right? We have these brackets, right? And what we need to do, we just need to return whether the parenthesis is valid or not, right? So now, when a parenthesis is valid, open brackets must be closed by the same type of bracket. Let's say, for this example, we have this opening bracket, simple opening bracket, and correspondingly, we have closing bracket, right? We have closing bracket, right? So now, again, after this, we have square bracket, opening square bracket, and we have closing square bracket. And same goes for curly braces. So overall, this parenthesis can be considered as valid parenthesis. Why? Because it satisfies all of these three conditions. And keep this thing in mind, like open bracket must be closed in the correct order, right? So now this example also state like since this is the valid parenthesis, so that's why we return true over there, right? And let's take a different example so that this thing will be clear to all of you guys. Let's take this example. We have string, right? So now over there we have first of all this opening bracket, right? And correspondingly, just follow these arrows, right? First of all, corresponding to this, we have this like this closing bracket. Corresponding to this opening bracket, what we have this, this, and this. That is why these is also a valid parenthesis. That's why we return 3 over there, right? Like once again, I'm doing this thing for you. Like for this bracket, we have this bracket, this closing bracket, right? And for this bracket, we have this, and these are closed in the correct order. Open brackets must be closed in the correct order. This condition is satisfied over there, and correspondingly, this square bracket is closed by this, and this curly brace is closed by this, and these are so all of these are closed in the correct order. It's not something like this, like let's say after this curly brace over there we have something like this. So this can't be a valid parenthesis, right? Because over there we have like just try to analyze this. Uh, this closing bracket, this opening bracket will be matched to this, right? And after this, like how we can assure that like this curly brace is matched with this curly brace, right? That's why it is not a valid parenthesis, right? When we add closing square bracket over there after a curly brace, right? So this is a valid parenthesis because it satisfies all of these three rules, right? So now let's jump into the approach and try to figure out how we can solve this question, right? So now let's take the same example as we take above. We have string this, right? This was our string, right? So now let's try to analyze how we can approach this question, right? So now, like whenever we try to process all of these brackets, the most recent opening bracket that hasn't been matched with a closing bracket is the most relevant, right? Therefore, like using a data structure that follows the last in, first out principle, such as stack, is quite intuitive, right? Like I hope all of you guys get why we are using like stack, like how we are using stack. Like this is another question. Like when an opening bracket is encountered, let's say we have opening bracket, all of this, right? These all three brackets are opening bracket. So whenever we encountered a opening bracket, it's pushed into the stack, right? So now because like we try to maintain a order in which all the brackets have something like this, because like after this will be matched directly with with its corresponding closing one, right? And opening bracket should be matched with the closing one. That's why we kind of need like something, we need to follow LIFO. That's why we require stack, because we currently need the last one. And let's say after this, like, just take this example. This example, like over there we are on this, in on this like closing bracket, right? So for this, what we need to do, we just need to analyze what will be its like whatever there is present on the stack, on the stack top, like st dot top, right? This, is it matching with the current element or not, like current bracket or not? So that's why we are using, like we don't need to care about like this, right? Because like this can be matched afterwards, right? Later on. First of all, we need to consider this one, because this both brackets should be matched, right? That's why we are using stack. I hope all of you get the intuition like why we are using stack over there, right? And moreover, each closing bracket should match the most recent unmatched opening bracket, right? Since a stack keeps track of the most recently added element, like over there, like on the top of the stack, we have the most recent, and each closing bracket should match the most recent unmatched opening bracket, right? So stack helps to maintain these matching principle, right? This matching principle, like right? Whenever a closing bracket is encountered, like whenever we encountered a closing bracket, let me write this thing, like whenever a closing bracket is encountered, what we need to do, it can be compared with st dot top, right? This matching principle. Remember, guys, with the top element of the stack to check if they form a valid pair or not. If they do, the opening bracket, like if they do, what we need to do, then the opening bracket is popped from the stack, right? Indicating that it has been matched. Will indicate that it has been matched, so that afterwards we can consider other pairs also. If they don't match, it implies an invalid configuration, right? So like using a stack allows for efficient checking of bracket pairs, right? That's why we are using stack. So now let's do a dry run for the above example so that you guys have a better understanding how this works, right? Take this string again. This was the string, right? We have, right? We have opening bracket as, and the closing bracket as, right? So now let's say we have our stack, right? So when we need to push, we need to push all the opening bracket into the stack, right? So when, let's say, initially we start traversing over the entire string, now our pointer is pointing to the first element over there. So since it's a opening bracket, so it will be directly pushed onto the stack. This will also push onto the stack, right? So whenever we encountered a op closing bracket, then we need to compare with the st.2 stack's top element. So this will be compared with this. If they form a pair, then this element will be popped, right? So now our pointer will be to this. Since this is opening bracket, so it will be goes into our stack, right? So again, this will be into our stack. So now this will be into our stack. So this will be matched with this. So they form a valid pair, right? First one is this, second one is this, second combination, right? This one, right? So now it will be popped from the stack, right? So now our pointer will be pointing to the curly brace closing bracket, right? So it is matched with the st.top. So st.top over there is this, and they form a valid pair again, right? They form a valid pair. So now this will be popped from the stack. Now our pointer will be pointing to this. This will be matched, and the fourth one will be this will be matched with this, right? That side is also popped from the stack. Now our pointer will be pointing to the end of the string. So this will be match, right? So whenever our stack, right, like whenever st.empty is true, then like after like doing all of these sort of comparison, like we need to check whether our stack is empty or not, right? This will be the like edge case, because at the end of the dragon, we like our stack will not should not contain any element in the stack, right? Because it's the indication, like we found a valid parenthesis for the entire stack, right? I hope this approach is clear to all of you and the intuition behind this and why we are using stack, right? So now let's try to code this thing up so that this will be clear to all of you guys, right? So here we are. So initially, let's create the stack, right? Let's take the size of the string also. And we'll run a loop. To iterate over the entire string. Now we'll check if so5 is equal to. So whenever we found the opening bracket, what we need to do, we just need to push all the opening bracket into our stack, right? So so5 is equal the square bracket, right? Or so5 is equal to the curly brace also, right? Down. What we need to do, we just need to push this thing into our stack, right? Else, let's say if our stack is empty initially, then we just need to return false, right? Now we'll directly get the st.top so that we can do the comparisons, right? Now we'll directly pop, right? Now we'll check if s of I is equal to the closing bracket, and then the topmost element should be the opening one, right? Or s of I. Now we'll do the same thing for other brackets also, right? Same goes for curly brace. So they will have RCH is equal. right? Then what we need to do, we just need to continue our process. Else, when they do not form any pair, just need to return false, right? So now after iterating over the entire string, what we need to check? We need to check if our stack is empty or not, right? If it's hold true, then we just need to return true. Otherwise, false. I guess we are good to go. Yeah, well, there we have some typo. Yeah, this perfectly fine. Now let's submit this. Yeah. So now let's discuss the time and space complexity for the same. So here we are. Since we are using stack, and in the worst case, our stack like will contain all the string. So this will require big of n space complexity, right? And when you talk about the time complexity, since we are just iterating over the entire string, so it will require big of n time, right? I hope this approach is clear to all of you guys, right? Please do like, share, subscribe, and comment if you have any doubt. Thank you so much.